It really hits you when you see the big picture, you know. We often think of environmental issues as these sort of slow, creeping problems, but um, the numbers on forest loss are just staggering.
They really are.
Since the 1960s, we've lost over half of the world's tropical forests. That's according to the IUCN. And, well, even right now, we're still losing more than a hectare of it every single second.
Wow.
It makes you realize how critical it is to stay, well, informed about what's really happening.
It absolutely does. And that's really why today we're diving deep into two interconnected issues right at the heart of this crisis: deforestation and habitat fragmentation.
Okay.
And while they often go hand in hand, it's important to understand them as distinct processes. They have their own unique impacts, as outlined by sources like the IUCN, but also Wikipedia, the Wildlife Society.
Okay, so let's get clear on the basics first.
Yeah.
Deforestation. The IUCN defines that as essentially converting forests to other uses, like agriculture or building roads, that kind of thing. Seems pretty straightforward.
Exactly. That's the basic idea. And then habitat fragmentation, which is detailed by groups like the Wildlife Society and also in academic work from places like Portland State University. That's the breaking apart of these large continuous habitats into smaller, more isolated patches. Now, this often happens alongside deforestation, obviously, but you can also get fragmentation even if the total amount of forest stays, you know, roughly the same.
How so?
Well, imagine a large forest, right? And then a new highway cuts right through the middle. You technically still have the same area of forest, maybe, but it's now in these smaller, disconnected chunks. That's fragmentation.
Gotcha. Okay. And for this deep dive, we've really pulled together a wide range of sources, haven't we?
We certainly have.
We got the IUCN giving that crucial global view, in-depth academic research looking at the real nitty-gritty of fragmentation from Portland State and PLOS One, the Practical Insights in the Wildlife Society and the Center for Large Landscape Conservation on, you know, how this actually affects wildlife moving around.
Yeah, the real-world impact.
Exactly. And even look at how new tech, like drones from JOUAV, is helping us monitor what's happening, plus Wikipedia for that solid overview.
And what's particularly insightful, I think, is how each source kind of sheds light on a different facet of the problem.
Right.
The IUCN gives us the sheer scale, the human consequences. Then the academic work dissects the ecological mechanisms, you know, what's really going on biologically.
And the conservation groups.
They offer that vital, real-world perspective on biodiversity. And like you said, the JOUV article shows us the evolving tools we're getting to understand and hopefully tackle these challenges.
So our aim today is really to synthesize all of this.
Yeah.
We want to cut through the complexity, give everyone listening a clear picture of why deforestation and habitat fragmentation are such, well, major threats, what causes them, what the effects are, and they're far-reaching, and then look at some potential solutions. We're aiming for those aha moments, really, to help understand this critical issue.
Okay, let's start by really trying to grasp the scale here. The IUCN's data, as you said, paints a pretty stark picture. Over half the tropical forests gone since the 60s.
Yeah.
And that loss continuing at, what was it, over a hectare a second.
Yeah, incredible.
And it's not just a tropical issue either. The IUCN also estimates that around 3.7 million hectares of Europe's forests are damaged every year. Now, that's from various factors, often linked to human activity, things like livestock grazing, but also insect outbreaks, diseases, fires.
Wow. 3.7 million in Europe alone. Those numbers are really sobering. And as the IUCN emphasizes, this isn't just about losing trees, is it?
Not at all.
This degradation, this loss of forest, it directly imperils the survival of so many species.
Right.
And it undermines those essential ecosystem services that forests provide for all of us.
Precisely. And if we connect that to people, the IUCN highlights that a staggering 1.6 billion people depend directly on forests for their livelihoods.
1.6 billion.
Yeah. And what's maybe even more striking is that 1 billion of those folks are among the world's poorest. So when we talk about deforestation, it's not just an environmental issue. It's fundamentally about global equity, human security. Losing these resources can just destabilize whole communities.
You mentioned the threat to species earlier, the IUCN stat. Over 80% of the world's terrestrial biodiversity is found in forests. Such an incredible concentration of life.
It really is.
So when these forest habitats are lost or broken apart, what are the direct consequences? for those species.
Well, this is where understanding both habitat loss and habitat fragmentation becomes so crucial. Sources like Wikipedia and the Wildlife Society really lay this out.
Okay.
The simple reduction in the total amount of forest. Well, that directly cuts down the available space and the resources species need just to survive. That's habitat loss. Pretty straightforward, if devastating.
But fragmentation adds another layer.
It adds a significant layer of complexity, yes.
So in what specific ways does fragmentation threaten biodiversity, beyond just losing the total area?
Okay, so fragmentation creates these smaller, more isolated patches of habitat. The Wildlife Society points out that this isolation can physically stop animals from moving between areas.
Right, like looking for food or mates.
Exactly. Food, mates, shelter, the essentials. And this isolation can lead to increased inbreeding within those trapped populations because there's no genetic exchange happening.
Which limits their ability to adapt, makes them more vulnerable.
Precisely. Their adaptability goes down, vulnerability goes up. Wikipedia also mentions something called the rescue effect.
The rescue effect.
Yeah, it's where a population that's struggling, maybe dwindling, can be sort of rescued by individuals arriving from a healthier population nearby. Fragmentation makes that much, much harder. It limits that natural recovery mechanism.
So it's like trapping wildlife in these shrinking islands of habitat, and they just can't interact with other groups anymore. That makes total sense for their long-term survival chances, or lack thereof.
Exactly. And then on top of that, we have what are known as edge effects.
Edge effects.
Both Wikipedia and the Wildlife Society detail these. When you break a large forest into smaller pieces, the amount of forest edge, that boundary between the forest and whatever is outside it, like a field or a road, increases dramatically relative to the interior area.
Okay, so more edge, less middle.
Pretty much. And these edge areas experience really significant changes in their microclimate. Things like more sunlight getting in, higher temperatures, stronger winds.
Ah, so it changes the conditions inside the fragment, too.
Yes, these altered conditions can penetrate quite a distance into the fragment, making that part of the forest less suitable for species that really depend on the stable, shaded, humid conditions you find deep inside a large, intact forest.
And that PLOS1 article mentioned these edge effects aren't always the same everywhere. They can vary.
That's right. They can be quite variable depending on the local landscape, what's next to the forest fragment matters, and even things like short-term weather patterns.
So it makes it even harder to predict the consequences.
It does. Factors like, is the adjacent land agriculture? Is it a road? Is it maybe even a different type of forest? All that influences the nature and the extent of the edge effect. Even wind direction can play a role. So yeah, two forest fragments that look similar on a map might actually experience very different ecological changes along their edges.
We also touched on isolation. It's not just about how far apart the patches are, is it? It's also about how easy it is for animals to actually move through the landscape in between.
That's a really crucial distinction. The Center for Large Landscape Conservation highlights this difference between structural connectivity and functional connectivity.
Structural versus functional.
Structural connectivity is basically the physical layout. Are there patches? Are there corridors connecting them? It's what you might see on a map. But functional connectivity is about whether the organisms, the animals, can actually move between them.
So, like, the stepping stones might be there, but can the frog actually make the jump?
Exactly that. The landscape might look connected structurally, but if a particular species just can't or won't cross the areas between the good habitat patches, what scientists call the matrix, then it's functionally isolated, even if the patches are physically close.
And this lack of movement, as Wikipedia noted, that leads to serious genetic issues over time.
It really can. Smaller, isolated populations are much more susceptible to losing genetic diversity, just a random chance. Basically, that's genetic drift. And they also face a much higher risk of inbreeding, which can lead to what's called inbreeding depression, basically, a decline in the overall health and reproductive success of the population.
Okay, shifting focus slightly.
Yeah.
Beyond biodiversity, what about the impact on people? Sustainable livelihoods. The IUCN mentioned 1.6 billion people depending on forests.
Absolutely. The implications are profound. Think about something as basic as soil, healthy soil. When you clear forests, you lose that protective tree cover, the root systems. And the soil becomes incredibly vulnerable to erosion by wind and rain. The IUCN states that already something like 52% of the land used for food production globally is moderately or severely impacted by soil erosion.
Wow, over half.
Yeah. And a lot of that is linked back to deforestation. This directly undermines farming, food security for countless communities.
And then there's the huge one, climate. Forests and climate regulation. This is something we hear a lot about.
A massive connection. The IUCN highlights that the world's forests are just enormous carbon sinks. They absorb about 2.4 billion tons of CO2 every single year.
Billion, with a B.
Billion with a B. Now, to put that in perspective, that's roughly a third of the annual CO2 emissions we pump out from burning fossil fuels.
So forests are soaking up a third of our fossil fuel mess.
Essentially, yes. So when we destroy forests, it's a double whammy. We not only lose that vital capacity to pull carbon out of the atmosphere.
And release the carbon stored in the trees, too.
Exactly. Deforestation and forest degradation themselves release enormous amounts of stored carbon back into the atmosphere. It's a huge contributor to climate change.
It's a truly vicious cycle, then. Lose the sink, add to the source. And the IUCN also pointed out, forests aren't just about storing carbon, right? They help us adapt, too.
That's a critical point. Healthy forests act as natural buffers against a lot of climate-related hazards.
Like what?
Well, they can provide a safety net, food, fuel, other resources, especially during extreme weather events. They reduce risks from disasters like coastal flooding by acting as natural barriers. And they help regulate local water cycles and microclimates, making everything, both human systems and natural ones, more resilient as the climate changes around us.
Okay, let's maybe dive a bit deeper into habitat fragmentation itself. There was that paper by Farrig from Portland State you mentioned that really looks closely at how we define and measure it. It sounds like it's more nuanced than just, breaking stuff up.
It is, and that's a key takeaway from Farrig's work. She argues, quite forcefully actually, that many studies haven't clearly separated the effects of habitat loss, just removing habitat, from the effects of fragmentation per se.
Fragmentation per se, meaning just the breaking apart, even if the total amount stays the same.
Exactly. The breaking apart independent of any net loss. And this distinction is really important because it affects how we think about conservation. Habitat loss itself generally has these large, consistently negative impacts on biodiversity. Pretty much always bad.
Okay.
But the effects of fragmentation alone, once you account for the loss, can be more varied, sometimes negative, sometimes neutral, sometimes even positive for certain species or processes.
Positive effects.
Oh.
From fragmentation, that sounds completely counterintuitive given everything we've just said about isolation and edge effects.
It does sound odd at first, yeah. But Farrig's review suggests a couple of potential reasons. For instance, if you keep the total amount of habitat the same, but increase fragmentation, it means the remaining patches are smaller, yes, but they might actually be closer together on average.
Ah.
So for some species that are pretty mobile, this could potentially reduce isolation, make it easier to move between patches. Also, some species actually thrive in edge habitats, or they need access to different kinds of habitat patches close together. Fragmentation can increase the amount of edge and mix up habitat types, which could benefit those particular species.
Huh. That's a really interesting twist. So the way we measure fragmentation needs to account for this distinction too, right? Farrig pointed out that common metrics like how big the patches are or how isolated they seem are often tied up with how much total habitat is left anyway.
Precisely. You often find smaller, more isolated patches in landscapes where there's just been a lot of habitat loss overall. So if a study just looks at, say, patch size and the number of species, it might be accidentally measuring the negative effect of losing habitat, not necessarily the effect of the pattern of fragmentation itself.
I see.
So Farrig really emphasizes needing methods, study designs, that can tease apart these independent effects loss versus fragmentation pattern to get a clearer picture of what's really driving changes in biodiversity.
And what about that landscape divergence hypothesis from the PLOS-1 article? What does that suggest about how species might change across different fragmented areas?
Right, the landscape divergence hypothesis. It proposes that because things like edge effects are so variable, influenced by local conditions, maybe even chance, habitat fragments within the same general landscape might actually become more similar in their species makeup over time.
Similar? Why?
Because they're all experiencing similar regional factors, the same climate trends, the same pool of potential colonizing species, similar large-scale disturbances maybe. But fragments located in different landscapes, facing different local conditions and pressures, might actually diverge, become more different from each other in terms of the species they contain.
Okay, that's quite different from the older idea of nested subsets, isn't it?
Yeah.
Where you just expect smaller fragments to have a predictable smaller subset of whatever species are in the bigger fragments nearby.
Exactly. Nested subsets implies a more predictable loss of species. Landscape divergence suggests fragmentation could actually lead to greater variety, greater heterogeneity in biodiversity across a whole region. You might end up with different fragmented landscapes harboring unique combinations of species.
Which has big implications for conservation planning.
It really does. It suggests that protecting a network of fragmented habitats across different types of landscapes might be crucial for safeguarding a wider range of biodiversity, not just focusing on the biggest remaining patches.
Okay, given this immense scale of deforestation and these complex, sometimes counterintuitive effects of fragmentation, it can feel a bit overwhelming. What are some of the key solutions? What strategies are being pursued?
It is a huge challenge, absolutely. But there is a growing global effort focused on solutions. The IUCN, for example, strongly advocates for something called forest landscape restoration, or FLR.
Forest landscape restoration, FLR.
Yes. And this is really important. It's a nature-based solution that goes way beyond just planting trees, which is what many people think of.
Okay.
It's a much more holistic approach. It aims to reverse deforestation and land degradation to restore the ecological functions, yes, but also the social, climatic, and economic benefits that forests provide across an entire landscape.
So not just reforestation in the classic sense.
Not at all. FLR includes a whole range of activities tailored to the specific place. It could involve helping natural forests regenerate, assisted planting, using agroforestry systems, integrating trees with crops or livestock, measures to control erosion, improve soil health, and crucially, FLR also focuses on tackling the underlying drivers of deforestation. Things like unsustainable farming practices, illegal logging. It involves engaging local communities, stakeholders right from the planning stage. It's about finding land use solutions that work for both people and nature.
The IUCN also mentioned the bond challenge. That sounds pretty big.
It is indeed. The bond challenge is a global goal. Restore 350 million hectares of degraded and deforested land by the year 2030.
350 million hectares.
Huge ambition. It was launched by IUCN and the German government, and it's gained real momentum. Governments, NGOs, private companies, they've collectively pledged to restore over 210 million hectares so far. A really vital undertaking.
And how do countries figure out the best way to do this restoration within that bond challenge framework?
Well, the IUCN provides support through a specific methodology called ROAM, the Restoration Opportunities Assessment Methodology. This framework helps countries assess, first, how much land is degraded and why, and then identify the most promising and cost-effective restoration strategies for their specific situation. The IUCN mentioned examples like Malawi using ROAM to integrate sustainable agriculture to boost food security while easing pressure on forests.
Right.
And Colombia using it to help prioritize restoration in areas affected by past conflict, so it's very practical.
We also talked earlier about the critical importance of connecting fragmented habitats. The Center for Large Landscape Conservation really emphasized habitat corridors and landscape connectivity.
Yes, these are absolutely essential strategies. Essential for the long-term survival of many ecosystems, and especially important for helping wildlife adapt to climate change, allowing them to move as conditions shift.
But we talked about structural versus functional connectivity.
Right. Structural is the physical presence of linkages. Functional is whether animals actually use them. Habitat corridors are basically pathways, often linear strips of habitat connecting larger patches. They help animals move, help genes flow between populations, and they don't have to be narrow strips. What matters is that they work for the target species.
And there are different types serving different needs, like migration, dispersal.
Exactly. Migration corridors for seasonal movements, dispersal corridors allowing young animals to find new territories, which maintains genetic diversity, and even commuting corridors for animals moving daily between, say, feeding and resting areas. The Center for Large Landscape Conservation also used the broader term linkages.
Linkages?
Yeah, referring to larger, maybe more diffuse areas that facilitate connectivity for a wider range of species and ecological processes, not just a single defined route. And beyond corridors and linkages, they also stressed landscape permeability.
Permeability. How easily things can move through the landscape generally.
That's it. The degree to which the whole landscape, including the areas between protected areas and corridors, the matrix we mentioned, allows or hinders wildlife movement. This really highlights that it's not just about the designated conservation bits. The entire mosaic of land uses matters for connectivity.
So it's about the whole picture, not just the green blobs on the map. We also touched on a whole suite of other potential solutions, too. Direct restoration, reforestation projects, like the Atlantic Forest, Costa Rica.
Yep, those are key. But also things like proactive sustainable land use planning. Germany was mentioned as having some examples. Plus establishing conservation easements, providing incentives for private landowners to manage their land well for biodiversity, promoting sustainable farming like agroforestry.
Right, integrating trees.
Creating green spaces in cities. Singapore's City in a Garden is a famous example. And of course, having and enforcing strong environmental laws and policies and public awareness, education, groups like WWF championing that. That's fundamental too.
In technology, we can't forget that. It seems like tech is offering increasingly powerful tools, especially for monitoring and helping restoration. That JOUAV article on drones really showed that.
Drones are proving incredibly valuable, yes. Getting detailed, up-to-date habitat maps, tracking how fragmentation changes over time, monitoring wildlife itself, assessing vegetation health, detecting illegal stuff like encroachment or logging, and even helping target restoration efforts by precisely identifying where intervention is needed most. That JOUAV CW25E drone they mention, with its long flight time and sensor capacity, is a prime example of how this tech is being used right now in the field.
And finally, the Wildlife Society, they gave that really comprehensive list of specific conservation tactics, everything from wildlife corridors and buying critical land to conservation easements, restoration projects, mitigating development impacts, zoning rules, buffer zones, even building wildlife crossings over roads.
Yeah, that represents a really diverse toolkit of on-the-ground actions. It shows that these problems can be tackled in many ways, tailored to the specific place and the specific threats. It really underscores that there's no single silver bullet. We need a multifaceted, integrated approach, combining good conservation science, sustainable development, tech innovation, and strong policies.
So bringing all together is just crystal clear that deforestation and habitat fragmentation pose these incredibly significant interconnected threats. Threats to biodiversity, threats to livelihoods for billions, threats to our climate stability.
Absolutely.
And addressing both the sheer loss of habitat and the breaking apart of what's left seems absolutely crucial.
It is. We've seen how habitat loss, the quantity issue, has that consistently negative impact. And fragmentation, the pattern issue, adds all these extra layers of complexity, isolation, edge effects, disrupting processes. Effective conservation just has to consider both the amount and the arrangement of habitats.
And, well, that really leads us to our final thought for everyone listening.
Yeah.
Given these ever-increasing pressures on our natural landscapes, from development, how can we, as individuals, as societies, best navigate this complex challenge of balancing our human needs with a really urgent imperative for habitat conservation, for connectivity? How do we actually ensure a sustainable future where both people and the incredible diversity of other life on Earth can actually thrive? Or, maybe another angle, considering how complex it is to even measure and fully understand the long-term effects of fragmentation, what role should precaution play? How cautious should we be in our conservation decisions when we don't have all the answers?
Big questions.
Definitely a lot to consider, but we really hope this deep dive has given you a more informed perspective on these critical issues and maybe some insight into the potential pathways forward.